Satoshi Nakamoto, the anonymous creator of Bitcoin, is often seen as a genius, and while this is true, he built on the work of others who had been trying to piece together the digital cash puzzle for decades. His true genius was putting all of this together and adding his own final pieces that make Bitcoin work. So in today's video, I'm going to walk you through each piece of the puzzle and end with Satoshi's innovation that make Bitcoin what it is today. Let's start with the blockchain. This is a ledger that records information across a network of computers. The idea goes back to 1991. When Stuart Haber and Scott Stornetta figured out how to make digital documents tamper-proof using cryptographic timestamps. Picture this like a giant library logbook. Every new entry gets its own fingerprint, and the librarian also copies the fingerprint from the page before. That way, each page depends on the last. If someone tried to change an old entry, every page after it would break, making the forgery obvious. In 1992, they improved the idea by grouping entries into bundles or blocks. So instead of stamping one page, the librarian could group 10 pages together and stamp them all at once. This made the system more efficient, and the foundation for what we call blockchain today was born. 16 years later, Satoshi combined this idea and applied it to money. So instead of documents, it tracked transactions. Each block carries a hash or a code that's tied to the one before it. And this creates a chain that's practically impossible to change without doing all of the work that comes after. And this system was perfect for money where trust is essential. But there was still a missing piece here. How do you know who owns what Bitcoin? To make Bitcoin work, Satoshi needed a way to prove ownership, and he solved this with digital signatures and something called UTXOs. This starts with something called public key cryptography. It creates a pair of keys, one public and one private. Think of the public key like an email address. People can use it to send you messages, but they can't send anything on your behalf. The private key is like your password. Only you know it, and it proves the real owner of the account. The concept was invented in 1976 by Whitfield Diffel and Martin Hellman, and the first digital signature algorithm came a year later from Revest, Shamir, and Adelman, what we now call RSA. In 1985, Neil Koblitz and Victor Miller introduced elliptic curve cryptography, a more efficient version that later became the standard and the one Satoshi used for Bitcoin. With this technology, anyone could create a Bitcoin address and receive funds, and then they could use their private key to prove they own those funds when they go to send them. But ownership alone wasn't enough. The system needed a way to make sure that the same Bitcoin couldn't be spent twice. One of the inspirations here came from Hal Finney, who in 2004 created a system called reusable proof of work. This showed how you could track digital tokens by destroying them when they were spent and creating new ones for the receiver. This is a model that made coins behave more like physical cash in your wallet. Satoshi then expanded on this idea with his own version called UTXOs. This stands for unspent transaction outputs. And instead of a balance in your account, Bitcoin tracks chunks of Bitcoin in your public address using digital receipts. You can think about it like cash in your wallet. You might have $50, but in different bills. So a 20, 2 10s, and 2 5s. If you spend $27, you hand over a 20 and a 10, and you get new bills back as change. And Bitcoin works the same way. So once a UTXO is spent, the output is destroyed and new outputs are created as your change. This way, the entire network can see which coins are valid or not. All right, so at this point, Satoshi had figured out a way for people to hold Bitcoin securely and a way to ensure that coins couldn't be spent twice. This is something that other digital currency attempts had never fully solved. But to remove the need for a central authority, Satoshi needed to solve another problem. How do you get thousands of computers all over the world to speak to each other without the need for a central server? The next piece of the puzzle is called peer-to-peer networking. This technology allows computers to connect directly to each other without using a central server, like how Twitter or Instagram might to store your posts and communication in one place. You can think of this like gossip in middle school. You tell a few friends, they tell their friends, and soon the whole school knows. That's how information spreads in a peer-to-peer network, like a web. Instead of going out over the intercom for everyone at once, it spreads like wildfire from computer to computer. This idea started with a government-funded group called ARPANET in the 1960s and was made famous by Napster in 1999 and then perfected by BitTorrent in 2001. By removing the middleman, it proved that peer-to-peer networks could scale globally. And Satoshi used this same design for Bitcoin. Transactions and blocks spread directly from computer to computer. And no one can shut this down because anyone that's running the software can go offline and then rejoin the network and sync back up instantly whenever they want. By default, each node or version of the software is connected to 8 other peers, and through this link, new transactions ripple out until everyone on the network is in sync. But gossip alone wasn't enough. Satoshi needed a way for all of the peers to agree on which version of history was correct. Now comes the piece that makes Bitcoin secure, called proof of work. This is what people mean when they talk about Bitcoin mining. Miners burn electricity trying to solve a difficult puzzle. The first one to solve the puzzle adds a block to the blockchain and earns a reward for doing so. And because everyone on the network can quickly verify that the puzzle is correct, everyone can agree on the same history. If you think about this like a casino full of gamblers at slot machines, everyone's pulling the lever, burning energy, and the first to hit the jackpot wins. It's tough to do that, but easy for everyone else around them to check to make sure that the win was real. The idea was first introduced in 1993 by Cynthia Dwork and Moni Naor, and later implemented in 1997 by Adam Back as Hashcash. It required computers to solve a puzzle before sending an email to fight spam. So for normal users, this was invisible, but for spammers sending millions of emails, the cost really piled up. Satoshi then took this technology and applied it to money. So when a block is mined, all of the nodes can verify that the work is correct, and then this block gets added to the longest chain. This process is called consensus, and it keeps everyone on the network on the same page, and it prevents anyone from being able to change the order of blocks. Proof of work makes cheating or changing any of the blocks on the ledger extremely expensive. Every block mined is a wall added to the fortress. With each block added, Bitcoin's history becomes harder to change and more difficult to stop. But there was still something missing because mining speed isn't constant. If blocks came too fast, new coins would flood the system. If blocks got solved too slow, then transactions could grind to a halt. To fix this, Satoshi introduced one of his most brilliant and underrated ideas called the difficulty adjustment. How this works is every 2016 blocks, roughly every 2 weeks, Bitcoin's code checks the pace at which miners are finding blocks. It targets blocks to be found every 10 minutes. So if miners are finding blocks faster than this, the puzzle gets harder. If miners are finding blocks too slow, the puzzle gets easier. Think of it like a watch. The mainspring regulates the release of energy so the gears keep the correct time. Without it, the watch will run too fast or too slow. The difficulty adjustment is Bitcoin's mainspring, keeping the whole system in rhythm one block at a time. This ensures that Bitcoin's supply stays right on schedule, so no matter if miners join or leave the network or how powerful mining machines become, the Bitcoin system can correct itself automatically. This rule is built into the code, and it keeps Bitcoin's supply predictable and scarce. But Satoshi's genius didn't stop there. He had one final piece: the incentives that tie the whole thing together. Satoshi aligned the incentives within the system so that the miners who secure the network also benefit from following the rules. Bitcoin's design creates both competition and cooperation. Miners compete by trying to burn electricity and solve blocks faster than each other, but they cooperate to secure the network because the rewards don't have value if the system doesn't stay honest. Bitcoin turns greed into security, and self-interest becomes the glue that holds it all together. Earlier attempts at digital money show us why this is so crucial. In the 1990s, David Chaum's DigiCash created private digital money, but it relied on a central company to issue and manage it. So when the company went bankrupt, the system collapsed. And then in 1998, Wei Dai's B-Money introduced proof of work and even proposed rewards, but it never solved consensus, leading no reliable way to force agreement on one single ledger. Satoshi solved both of these problems by introducing adversarial thinking and aligning incentives using the block reward and transaction fees. This made the system more costly to attack and more profitable to play by the rules. Today, miners are paid mostly through new Bitcoin created in each block, with transaction fees as a smaller bonus. But over time, those block rewards shrink and eventually disappear. At this point, transaction fees take over as the incentive to keep miners honest and securing the network into the future. The alignment of all of these incentives are what allowed Bitcoin to succeed when all other attempts at digital cash in the past had failed. And when you take a step back, you can see just how perfectly all of these pieces of the design fit together. Satoshi's breakthrough was adding all of these inventions together, applying them to money, and then adding the difficulty adjustment and incentives to keep the network secure. Blockchain is the record, proof of work secures it, signatures prove ownership, the difficulty adjustment keeps time, and incentives tie it all together. Every piece is essential, and together they form a system that can't be stopped. When history is written, Satoshi Nakamoto belongs on the Mount Rushmore of inventors, with the creation of Bitcoin placing him alongside Leonardo da Vinci, Thomas Edison, Nikola Tesla, and the Wright brothers. I know all of this can seem really complex, but Understanding how all of Bitcoin's systems work together can give you the confidence you need to trust it with your hard-earned money. Because part of Satoshi's design wasn't just removing trust, it was replacing it with software, math, and incentives. So there's no middlemen, there's no banks, just computers, software, and exceptional engineering. My name's Austin. Thank you so much for watching, and I'll see you in the next video.